So in this video, we are going to see the other classification of signals, that is periodic and non-periodic signals. What is meant by periodic and non-periodic signal? A signal is said to be periodic signal if it repeats again and again over a certain period of time. That means if it follows a pattern after a particular time interval, then such signals are known as periodic signals. Now, these signals are said to exhibit a certain characteristics. That is, these signals follow this equation. That is, x of small t plus capital T is equal to x of t, where capital T is known as the time period of the signal. That is, this is the time after which the signal repeats the pattern. And the smallest value of t, that is time, which satisfies the above condition, is known as fundamental period of the signal. Now, such a signal can be represented by a mathematical equation and their value can be determined at any point of time. For example, you can take a sinusoidal signal. Now, the sinusoidal signal is a signal which repeats after a certain time interval. Now, if you see this particular point, now after this point, if you see this as one cycle, after this point, again after this much time, this is repeating the same pattern. So this is the time or the period after which the sinusoidal waveform is repeating the same pattern. So this time period is equal to 2 pi by omega. From where we are getting this equation? Now see this, W is equal to, or angular frequency is equal to 2 pi f, where f is equal to frequency in hertz. So f will be equal to angular frequency, that is omega, divided by 2 pi, and frequency is the inverse of time period. So f is equal to 1 by t means t will be equal to 2 pi by omega. So always the time period or the fundamental time period is considered as t is equal to 2 pi by omega. Now, what is meant by non-periodic signal? Periodic signal is a signal which repeats after a certain time interval. That means non-periodic signals are those signals that changes without exhibiting a pattern or cycle. It can be decomposed into infinite number of periodic signals using Fourier. Now, this is the example of a non-periodic signal. You can observe the signal. This signal is not varying after any time instant. That means it is not having the same pattern after any time interval. So this is a non-periodic signal. Now, there are certain conditions for a signal to be periodic. First condition is x of small t plus capital T should be equal to x of small t. That is a basic condition. Now, other than this condition, there are certain other conditions as well. That means if your signal is a combination signal, that is a sum of two periodic signal, how will you determine the combined signal is periodic or not? So the condition is that sum of two continuous time periodic signal x1 of t and x2 of t with periods t1 and t2 may or may not be periodic depending on the relation between t1 and t2. Now t1 and t2 are the time periods of the signal x1 of t and x2 of t respectively. Now the sum of these two periodic signal is periodic only if ratio of their respective periods, that is T1 by T2, is a rational number or a ratio of two integers. That means when you are provided with a combination signal, that is when x3 of t is equal to x1 of t plus x2 of t, you have to find out the time period T1 corresponding to x1 of t, T2 corresponding to x2 of t. Then you take the ratio T1 by T2. If you obtain the value T1 by T2 ratio as a rational number, then it is a periodic signal. Now, Once we have determined the signal is periodic, now the next step is to find the fundamental period. Now the fundamental period will be the least common multiple of T1 and T2. And sum of two discrete time signals is always periodic. There is no condition to be satisfied. Now, sinusoidal signals and complex exponential signals are said to be always periodic signals. Now, we will see how. Now, sinusoidal signal, as we know, the equation is x of small t is equal to sine omega 0 t plus phi, and x of t will be periodic if x of small t is equal to x of small t plus capital T, where capital T represents the time period. This is a condition. So now we will find what is x of small t plus t. That will be equal to sine omega 0 into, instead of t you have small t plus capital T plus phi. So that is, when you open this bracket, it will be sine omega 0 t plus phi plus omega 0 capital T. Now, the condition is that these two, x of t and x of t plus t, should be equal. That is, sine omega 0 t plus phi and sine omega 0 small t plus phi plus omega 0 capital T should be equal. Now, this has to be equal to sine omega 0 t plus phi, means this term omega 0 t should be equal to what? 2n pi, or it should be a multiple of 180 degree, because sine 180 plus theta is always sine theta. So we know omega 0 t is equal to 2n pi, means what? T will be equal to 2n pi omega 0. So when n is equal to 1, t is equal to 2 pi by omega 0. That is, x of t is periodic with fundamental time period t is equal to 2 pi by omega 0. That means all sinusoidal signals are always periodic with this fundamental time period t is equal to 2 pi by omega 0. Now next is exponential signal. Exponential signal, complex exponential signal actually, that is x of t is equal to e raised to j omega 0 t. Now for this to be periodic, condition is x of small t should be equal to x of small t plus capital T. So you just substitute e raised to j omega 0 t should be equal to e raised to j omega 0 into small t plus capital T. That is, e raised to j omega 0 small t should be equal to e raised to j omega 0 small t into e raised to j omega 0 capital T. Now, if this term is 1, then x of small t and x of small t plus t capital T will be equal. So the condition will be satisfied. Now, this term is 1, means we know e raised to j theta is equal to cos theta plus I sin theta. So when that equation becomes 1, magnitude of that equation becomes 1 when the angle is 2n pi. When this e raised to j omega 0 t in this equation, omega 0 t, when it is equal to 2n pi, the value of this particular term becomes 1. So we know omega 0 t has to be equal to 2n pi, the multiple of 180 degree, for it the condition to be satisfied. So we know t is equal to 2n pi omega 0 from this particular equation, and when n is equal to 1, it is a fundamental time period, t is equal to 2 pi by omega 0. So sinusoidal signals and complex exponential signals are always periodic in nature. Now we'll see some example. First question is sine 12 pi t. So we know sinusoidal signals are always periodic signals. So you just take, compare it with the standard form sine omega t. So when you compare, omega is equal to 12 pi. So omega is 2 pi f, that is equal to 12 pi. So from this, frequency is equal to 6 Hz, or time period is equal to inverse of frequency, that is 1 by 6 seconds. Next is complex exponential signal, that also is always periodic. So omega e raised to I omega t is the standard form. So omega is equal to 4 pi in this equation. T is equal to 2 pi by omega. Omega will be equal to what? It will be equal to 1 by 2 seconds. Next question, it is a combination signal. Actually, the product of two signals, sine phi t and u of t. Now sin pi t, we know it is always periodic signal. Now what is u of t? U of t is a signal like this, which is having a constant amplitude from t is equal to 0. That means in the left side you have no signal. So when you multiply these two signals, okay, when you multiply these two signals, you have sine signal here in the positive part continuing like this. Sine is here in the left side also. So when you multiply these two signal, what you are getting a signal which is existing only in the positive part. So that means your signal is now, since the value of u of t is always 1, when you multiply any signal with u of t, what you are getting is same signal itself. So you have a signal which is coming here in the positive part only. So in the left side, since u of t is 0, when you multiply, the value will be equal to 0. So such a combination, you can't say it is a periodic signal, because at this particular instant and this particular instant, if you see, it is not repeating that pattern. Here the value is 0, but here the value signal is having some value. So pattern is not repeating in this part. So the signal is not periodic. Next is x of t is equal to cos 2t plus sine root 3t. Now this is a sum of two signals where x of t is equal to x1 of t plus x2 of t. x1 of t is cos 2t and x2 of t is sine root 3t. Now what is the condition for checking whether the signal is periodic or not? You have to independently find the time period of x1 of t and x2 of t respectively, and then we will find the ratio. The ratio gives you a rational number, then it is periodic. So first you take T1. What is T1? T1 will be equal to 2 pi by omega 1. Here omega 1 is equal to 2. So 2 pi by 2, the answer will be pi. Now T2 will be equal to 2 pi by omega 2 here, which is 2. Not 1, this is omega 2. So omega 2 means value is root 3. So 2 pi by root 3 is T2. Now you take the ratio. When you take the ratio, root 3 by 2 you are getting. Now whenever you have something like root, pi, etc. coming in the numerator or denominator, ratio is not a rational number. It has to be rational number, means it has to be expressed in the p by q form, where p and q has to be integers. So x of t is non-periodic since root 3 is equal to 1.732. Now these are two practice problems. The solution of this will be given as next video. So thank you.